Uh, Good evening to you. Good evening to all of you. I hope you all can hear me properly. So, welcome to the 6th day of our class. And as I mentioned earlier, so we will be, as I mentioned to you, we will be discussing about measurements today. So actually, last week we discussed algebra, the graphs and the equations part. Yeah. So today I'm going to talk about the next big category, the measurements, which is related to area, perimeter, volume, and yes. And also I have added another one question which I didn't do under the algebra, solving a quadratic equation. So normally you get a quadratic equation question. It's kind of related to area also. Since I didn't discuss that quadratic equation part last week, so I have input that one question, like in under the essay questions, I have added one question. So from that, right? So it's about quadratic equation. So apart from that, today we will be discussing about basically area, perimeter, and volume. Okay. So I hope you have gone through the paper that I have shared with you. And also I hope you have your answers with you and the paper. If you don't have the paper with you now, let me know. Okay. So because when we are discussing the questions that you need to have the paper with you. So yes, since this is our 6th day, I'm not going to discuss about many things about our class because now most of you know about our class, and so today is actually the last day. So we are doing measurements. So as I told you last week also, we did numbers and then sets and probability and statistics, algebra, and today one day I did a one free seminar for the geometry, and today we are doing measurements. So which means we have finished our one cycle. So we have discussed in our last month we have discussed like one whole paper, right? Little by little we have discussed one whole paper. Like paper means actually we have touched each and every part in the paper. Okay, so this time again after this measurement, next week we are again starting with numbers, especially with, so last time I mostly focused on fractions. So this time I will be focusing on arithmetic progression, geometric progressions, and trigonometry too. Okay, so those are the things that I will be including in your next paper. And as I always say, if you have any suggestions and if you need any particular lessons to discuss, feel free to send a message. Okay, right. So without any further ado, let's move into our lesson today. Right. So how many of you have worked out today's paper? How many of you have worked out? Did anyone had any chance to work out the whole paper? No one? Right. Okay, let's start. And I think you can unmute your mic. I think you can. Check whether you can. So if you have any doubt, or if you, especially if you don't have the paper, please let us know, right? Otherwise, you won't understand anything that we discussed today. Okay, so let's move into the first question. Right, it says 1/2 of a tank is filled with oil. All right, Zara, don't you have the paper with you? Zara, are you in our group? Ah, okay, you have it. Okay. Right. Then let's move into the first question. So 1/2 of a tank is filled with oil. When 36 liters are removed, the remaining oil filled with 1/10 of the tank. Before I start this paper, I must tell you that I have created this paper based on your past paper questions. Okay, these are not like there are one or two model questions, but most of these are from past papers, right? So what you will be doing now is past paper questions. So the first 6 questions, so I have given you 6 short answer questions. So those are, I took those questions from the past papers. Most of them are from 90s. Okay, 1990 to 1999, right? Okay, because I chose them because you have to be prepared. The reason is this time, because of this COVID thing and pandemic thing, most probably you will get an easy paper. That easy paper means they don't give you like normal questions that you solve in your day-to-day life, right? Easy paper means that they will give you questions from past, right? Not the same exact question, like kind of those things, right? So that's why I pick those things. So they won't pick the questions like very near ones. So normally all the students are doing like past at least 10 papers now, 10 past papers now. So I'm going to take questions beyond that, right? So anyhow, you are doing 10 papers, right? 10 past papers. So I'll be choosing the questions from the previous parts. Okay, so the first question, it says 1/2 of a tank is filled with oil. When 36 liters are removed, the remaining oil filled 1/10 of the tank. The first question is asking what fraction of the total capacity of the tank is the amount of oil removed, right? Right, so there we have water tank. We have a water tank and it's half filled. And after that, they are going to remove 36 liters from this tank. They remove 36 liters. After they remove 36 liters, there are 1/10 of water remain. Sorry, 1/10 of oil remain. Okay. So when they remove half of the oil from the tank, there's 1/10 remaining in the tank. So after they remove this 36, we left with 1/10 of the tank. This is 1/10. Right. So the very first question, Roman number 1, it says what fraction of the total capacity? What fraction of the total capacity of the tank is the amount of oil removed? So we have to find how much oil that they have removed from this tank. That's what they are asking basically in the very first question. So we can just find the fractions that remove. It It's very easy. We had 1/2. After remove this part, we left with 1/10. So we can find the remove part by doing 1/2 take away 1/10. This is very simple. Okay. So we have to make the denominators here multiplied by 5. So it is 5/10. Take away 1/10. 5 take away 1 is 4/10. So this is the answer. We can simplify it. 2 times 2, 2 times 5. So it is 2/5. So why we did subtraction? It's because like this. Let's say we have 5 topics. Let's say I have 5 topics. For an example, let's say I have 5 topics, and from these 5 topics, a friend of mine comes and takes some number of topics, right? I have 5 topics. I know I have 5 topics, and friend of mine comes and takes some number of topics from this, but I don't know how much he took, right? But after he takes that, I left with 3 topics. After he took that amount of topics, I left with 3 topics. Okay, so the number of topics he taken, I can find by simplifying it with 3, which is 2. So if I have left with 3 topics, that means he has been taken 2 topics. Okay, so that's the same thing I did over here. Here we had half of oil, and after some amount of oil removed, we left with 1/10, and then we have to find how much they have removed over here. So what we have to do is 1/2 take away 1/10. So in order to do a fraction subtraction, we have to make the denominators, right? That's something we discussed in the very beginning under the fraction lesson. So when we are adding and subtracting fractions, we have to make the denominators same before we add or subtract the fractions. So then number 2. Problem number 2. Find the capacity of the tank. So this is the fraction that they have removed. The fraction that they have removed is 2/5. That is the fraction that they have removed. And here they are telling us the fraction they have removed is equals to 36 liters. So the fraction they have removed is equals 36 liters. So we have to find the total capacity of the tank. Capacity of the tank. So we can find the total capacity. This is 2/5. 2/5 is equal to 36. So I can find 1/5 by dividing this 36 by 2 and then multiplying by 5. Right? Because this one gives us 1/5, and then we can multiply it by 5. So then 2 times 1, 2 times 1. For 16 it is 8. 8 times 5, 0. 4 left, 9. So the total capacity of the tank is 90 liters. So this is how we should work it out. I hope you all get that. Then question number 2. That also a volume related question. So in question number 2, it says 25 liters of gingerly oil has been filled into bottles of 750 milliliters each. So altogether we have 25 liters, and they are going to pour it into 750 milliliters bottles. The first question is asking, accordingly, how many bottles? Accordingly, how many bottles each of 750 milliliters can be filled completely? So we have 25. So we have as a total we have 25 liters. As a total we have 25 liters, and we are going to pour it into 750 milliliter bottles, right? So we have to find how many bottles each of 700 milliliters can be filled completely. So it's again Simple math. What we have to do is divide 25 liters from 750 liters. So number of bottles equals 25 liters means 25,000 liters divided by 750 bottles. Sorry, 750 milliliters. So then we can find how many bottles are there. So 0 and 0 get cancelled off. I can cancel it off by 25. 25 times 1, 0, 0, and here 3. So it is 100 over 3. 100 over 3 means 3 goes into 10 3 times. 1 left. 3 goes into 10 3 times. Again 1 left. So it is 33 and 1/3. So they are asking how many bottles can be filled completely. So number of bottles that we can fill completely is 33. I can't take that 1 over 3. If you leave your answer this way, you don't get your full marks, right? Because this bottle, this last bottle hasn't been filled completely. So that bottle is, let's say, like this. So from this bottle, it has been filled only 1/3. There's another 2/3 is remaining, right? So this is not a completely filled bottle. I hope you understand. Then Roman number 2. In the Roman number 2, it says how many milliliters will be left behind. Okay, so there's a 1/3 remaining. This is the remaining part from the bottle. Okay, so we are going to pour this 25 liters amount of oil into 750 milliliters bottle. Right? When we are doing that, in the last bottle, we have only 1/3 of it. Right? So we have 1/3 of it. This total bottle is 750 milliliters. This total bottle is 750 milliliters, but it has been filled only 1/3 of it. Right? So we can find how that is the left amount. Right? In each and every bottle, other than this, in each and every bottle, which means all the 33 bottle has been completely filled, right? This is the bottle that haven't been completely filled, So this is the remaining amount after we pour those oil into bottles. So we can find the remaining milliliters, the remaining amount I can find from this total thing. We have filled 1/3, right? From that whole bottle, from this whole bottle, we have filled 1/3, that is the remaining part. So the whole thing is 750. From this 750, 1/3 has been filled. So 1/3 of 750, that is the amount that we have, that is the amount of oil which we have inside this bottle. So 3 times 1, 3 times 2, 5, 0. So it is 250 milliliters. So that is the answer for the second question. Right. So you can while I'm erasing the whiteboard. So it says, in the given figure, the length of AB of the rectangle ABCD is 12 centimeters and the length of the diagonal DE is 13 centimeters. Find the length BC of the rectangle. Okay, so this is what we have. They are asking the length of BC. That's it, right? So actually, they are telling us that this is a rectangle. So if this is a rectangle, we know all the angles are 90 degrees, which means that creates a 90 degree angle over here, which makes that DBC triangle is a right angle triangle. If we have a right angle triangle, we can apply the Pythagoras relation, right? So here we have to apply the Pythagoras relation. So if you don't know the Pythagoras relation, learn it now. So I'm going to apply the Pythagoras relation or the theorem. Pythagoras theorem to the triangle ABD. I'm going to apply the triangle ABD. Applying the Pythagoras relation to the triangle ABD. So this is how I should apply, right? So if you can't remember the Pythagoras relation, I will teach you now. So we can apply the Pythagoras theorem only to right angle triangles. Okay, we can apply Pythagoras relationship only to right angle triangles, right? So there is a way in your textbook that how that Pythagoras has proved this one, but we don't need it. Drawing squares for each side, we are not using that. We don't want it. What you want is how to find what is the relationship of the Pythagoras theorem, right? That's it. So the Pythagoras theorem says the square of the hypotenuse is equals to the addition of the squares of other two sides. That's what Pythagoras theorem says. So which means, what is the hypotenuse? Hypotenuse is the side which is in front of the 90 degree angle. This is the hypotenuse. How did I know? Because that is the side in front of the 90 degree angle. So the square of that hypotenuse is equals to square of the other two sides. Since I don't know this side, I'm going to take it as x. So let's apply the Pythagoras relation. So BD square of the hypotenuse. Square of the hypotenuse is BB square. Then the addition of the squares of other two sides. So the other two sides are DC and BC. So I can write DC square plus BC square. Then BE squares I can write 13 square equals DC squared I can write 12 square plus BC squared I can write x square. So 13 squared is 169 equals 12 squared is 144 plus x squared. Now I have to find the value of x squared. What I'm going to do is I'm taking 144 to the other side. When this 144 goes to the other side, it becomes negative because this is already addition. When I take it to the other side, it becomes negative. So when I take this 144 to the other side, this x squared remain alone in one side. So I'm writing that x squared in this side now. Other side we have 169 take away 144. Then 169 take away 144, 9 take away 4 is 5. 6 take away 4, 2. 1 take away 1 is 0. So x squared equals 25. Now I have to take the square root. So I'm taking the square root from both sides. So square root of x squared is x. Square root of 25 is 5. So the value of BC is 5 centimeters. So this is how we apply the Pythagoras relationship. If you don't understand it, you can ask from me. I think you can unmute your mics. You can ask from me if you have any doubt. So Roman number 2, it's asking the area of the rectangle. So actually it's pretty easy. So you know it's 12 and 5, so we can find area of the rectangle. I'm going to do it in here itself. Area of the rectangle. Area of the rectangle equals length is 12, breadth is 5, so it is length into breadth, which is 12 into 5. So the answer should be 60 centimeters square. Check whether you have put the units of the measurements, right? Check whether you have written the units, otherwise you are going to lose 1 mark. Okay, so that is the third question. And then I'm going to the fourth question. Right. In the fourth question, it says, in a square sheet of side 3r, 4 quadrants of a circle of radius r are cut off from the four corners. Four corners is in the figure. Obtain a formula in terms of pi and r to express the area of A of the remaining piece of the sheet. A quadrant of circle is one part of the circle. The area of a circle of radius r is pi r square, which means we have to write an expression for the remaining area, right? So you have been doing these kind of questions since grade 9. You have been doing these kind of questions since grade 9. So this is the figure that we have. So one thing we know that all these quadrants are equal in size because they are radii are circle. Now I can find the area of the square. Area of the square. Because first of all, I have to find the total area. First, I have to find total area. Then I'm going to find the shaded area. So from the total area, I'm going to subtract the shaded area. Then I get the area that I need. So the total area is the square. So area of the square is equals, one side in a square is 3r, it's given. In a square sheet of side 3r. So one side is 3r, so I can write this one as 3r into 3r, which makes it 3 times 3, 9, r times r is r square. So area of the square is 9r square. Now I can find area of a quadrant. Area of a quadrant so actually it's 1/4 of a circle. It's 1/4 of a circle. So the area of a full circle is pi r square. Area of a full circle is pi r square. It's given. Even in the question inside it's given. Even though if it is not given, in any case, you know the area of a circle is pi r square. Now quadrant means quarter of a circle. So now we have only quarter of a circle. So area of a quadrant is 1/4 of pi r square. So now area of one quadrant is that I have 4 of them. So I can find total shaded area. Total shaded area is equals 1/4 multiplied by pi r square multiplied by 4. Why? This is the area of one quadrant. So we have 4 of them. So we can multiply it by 4. So 4 and 4 get cancelled off. That is equals to pi r square. Wait, it's not on here. So that is the shaded area. Now I know the shaded area is pi r square and the total area is 9r square. So we have to find what they asked us to find. The remaining area of the remaining piece. So area of the remaining piece. Area of the remaining piece is equals, as a total we have 9r square. So we have 9r square, that's the total amount. And from that total amount, we are going to remove pi r square. Then I can take r squared out like this. And my final answer would be 9 take away 1. Since they haven't given us that we have taken that I is equal to 2 over 7, I'm not going to do that simplification, right? If you have done that, that's also okay. Here, if you want, you can take the value of pi as 22 over 7 and you can simplify it with 9. So 9 take away 22 over 7. Okay. Yeah, Dunisha, this is the fourth question. This is the fourth question. Okay. Fourth question is this. Question, we have a third question in here. Shakira, you mean the third question or the fourth question? Fourth, okay. Right. So in that fourth question, Shakira, the question is asking, there is a square. Okay. There is a square like this. There is a square like this, and from this square, they are going to cut these corners like this. This shaded area is going to be removed from this square, right? So the question is asking from us, find the remaining area. Remaining area means this one. So that's what we have to find. So what we did in here is, so first we have to find the total area. Before they are going to remove these four parts, these four corners, we have to find the total area. In the question itself, it's given that the side length of a square of the square is 3r. In the question is given in the very beginning, in a square sheet of side 3r. So one side, this side length is 3r. Since this is a square, all the sides are 3. So here what I did was, I first found the area of this total square. Okay, I found the area of this total square before they remove these quadrants. Quadrant means these corners. Okay, so 3r multiplied by 3r, because this is a square, we can find the area of a square by multiplying length into breadth. In a square, length and breadth are equal, so 3r into 3r, which gives me 9r square. 3 times 3, 9, r times r square. So first I have found the total of this square, which is 9r square. Then from this total square, I have to remove these four parts, right? Before I remove four parts, I have to find the area of one part, right? Before we go for the four, we have to find 1. Okay, so here I wrote area of a quadrant, which means 1 quadrant, right? Quadrant means 1/4 of a circle. That's what a quadrant means. Okay, so here what I did, like, if it is a full circle, we can find the area by using the equation pi r square. If it is a full circle, we can find the area by using pi r square. Since this is 1/4 of a circle, I used 1/4 of pi r square. If you don't understand why I used 1/4, I will give you another reason. So normally what we have to do is you have to put that angle. So the angle over here is 90 degrees. So we can find the area of a sector. You had in grade 10 in the perimeter lesson, I think the very first lesson. Okay, you have to find, you learn how to find the area of sectors. So this is a sector. We can find the area of that sector by using 90 over 360 into pi r square. That is the equation we use, right? We have to write the angle. So when we simplify the angle 0, 0, 9 times 1, 9 times 4, we get again 1 1. We get the same thing again, right? So the area of the quadrant is 1/4 of pi r square. Then I have 4 of them. I have 4 of them. So I written total shaded area. This is the shaded area. So it is 1/4 times pi r square. This is area of one quadrant multiplied by 4 gives me whole area of all the 4 quadrants. Okay, then 4 and 4 get cancelled off. I get pi r squared over here. Then I can find the area of the remaining piece. So we had 1 whole square. We had a 1 whole square. And from that 1 whole square, we are going to remove these 4 quadrants. From that one whole square, if we remove those 4 quadrants, what we have to write? The whole square is 9r square. 4 quadrants, the area of the 4 quadrants is pi r squared. So 9r squared take away pi r squared. Since r squared is common, I took r squared out. So answer is 9 take away pi. I hope you get it, Shakira. Okay. Yes, right. Then let's move into fifth question. Does anyone has any doubt with the third one? The Pythagoras theorem? Okay. Right. Then let's move into the fifth one. Students, actually Pythagoras theorem is not something related to the measurements, right? It comes under the geometry because it's one of the theorems. But I gave it to you in here because we can't actually categorize those lessons like geometry, algebra, statistics, likewise. Okay, they are all connected to each other, right? So don't worry about it. Even in volume and area questions, we have to solve fractions, right? We have fractions multiplication, fractions addition everywhere. So then all the lesson goes under number lessons. So actually it's hard to divide them into pieces. Okay, what I'm doing in here is I'm going to like instead of discussing from everywhere, right, without discussing all the syllabus from everywhere, I'm going to discuss the selected part so you can have an idea what you have to study. So I hope you are doing these papers before you come to the class so you can get a normal idea. So all right. Yeah. Yes, you can write, right? You can write 9r square minus pi r square. So that doesn't matter. Okay, so if you can factorize it, that's better, right? So normally that factorization part, they are not expecting in here, but if you have something, like make it a practice, make it a practice. If you can factorize something, just factorize it and show. Okay, so make it a habit, right? Because sometimes the reason is, sometimes when you factorize it, you can see that there are solvable things, right? Before you factorize, you can't see, but when you factorize it, you can see that there are solvable things, especially in algebraic fraction lesson, right? So in algebraic fractions, you make the denominator same, you add those subtract numerators, but if it is possible to factorize the numerator, factorize it, because sometimes when you factorize it, you can cancel the numerators and denominators, right? So here actually factorization doesn't use that much of thing. So if you leave your answer as 9r square minus pi r square, that also fine. Okay. So student, what I was going to tell is you have to get an idea what parts you need to improve, right? That's the whole purpose. So that's why I'm doing these lessons. This is a revision, right? I told you this is a revision. Here we don't just discuss the syllabus, we just pick a question and we just work it out, right? That's what we are doing in here. So, but the problem in this method is, so if you have a particular part that you don't understand, you might miss it, right? Because since we are not focusing on the syllabus, we are working out here and there. So sometimes if you, when we are doing a paper, if you miss one question, then you don't know you miss this question because you don't know this part, that particular part, right? You think that, okay, it's just a one question on the paper, right? You worked out all the other question, but you miss one question on the paper. One question on the paper because you don't know how to work it out. Even though it's a one question on the paper, right? That represent a particular part on the syllabus. That question is representing a particular part on the syllabus. So if you don't know how to work out that part, that means you have a gap, and we have to fill that gap. Okay. So by using online, actually I can't pay you individual attention. So that's why I'm always encouraging you to ask questions. Okay. So if you have any doubt, like just now Kishore asked, is it okay to write this way? Do we have to factorize in this way? So clarify your doubts. Okay, clarify your doubts always, because I can't see your papers. I don't know what you are doing there. So everything is up to you. I'm just a facilitator, right? So if you ask from me, I can deliver it to you, right? So now only that came into my mind. So next week onwards, when I'm preparing the paper, I will give you the marks also. Normally marks that you get, actually you can also mark. Normally that one small questions you get 2 marks, right? So that's how the paper is going to get marked. So actually, so far I haven't given thought about it, but next week onwards I will give you with the mark. So to the side I will give you how much you get for that particular question. Okay, so you can get an idea how much marks you get. So then you can analyze which part you need to work on more, right? So that's the importance of discussing the syllabus by categorizing them according to the mathematical topics, right? So if you get low marks for the measurement, then you know you have to revise area lessons, volume lessons, speed, distance, time graphs, and perimeter, circumference, final circumference, perimeter lessons. Okay, so if you are getting low marks for let's say equations, then you have to revise algebra parts. Okay, so you have to do, right? Because no one is there to help you, right? Teacher strike is still going on. I don't know. They have announced that they are going to start the school on 21st of October, but I don't know whether it's possible or not. So you have to do most of the thing by yourself. Even they start the school on 21st of October, you have November, December, January, February, you can't learn anything because you have to go for the O-level exam, right? So still they haven't postponed it officially. So now they have told that it's in February. They haven't postponed it officially. So maybe they will postpone it to the April with A-levels and grade 5 scholarship exam, but not sure. We don't have that much of facilities in our country. We don't have that much of teachers to do the supervisions. So that's a problem. Okay. So my point is you are on yourself, right? You are on your own. So you have to work it out. You have to identify your mistakes, because even if it is okay. So if you can, you have my number in the group. So if you, when you are working out questions, if you get a doubt whether you work it out in a correct way, in a wrong way, you can always send it to me and ask. Okay, that's totally fine. When I'm free, I will send you a message, but I can't tell you I will send you the reply like right after you send me the message. But somehow I will try. Okay, somehow I will try, or else you can discuss it in this class itself. It's totally fine. Right? If it is, if we can discuss it, I will discuss it with you with the whole class. If it is not, I will move it to the, I will give you the answer personally. Okay. So it's up to you. So you have to get the maximum thing out of this. Okay. Right. Then the fifth question. It is a trapezium. Okay, this is the question we have. So this whole thing is 18 centimeters. So I know that this is 8 centimeters because this is a trapezium, right? So here we have 90-degree angle. So these two are parallel. Okay. How did I know? If this is 90, this is also 90, right? So this is a rectangle. And here I have 8 centimeters. So this part is 8 and this part is 10. Okay, I can remove it into that part, that thing. So now I have to find the area of this trapezium, this whole figure. Actually, you don't have to do that much also. I hope you all know how to find the area of a trapezium. So area of the trapezium is equals. So this is the equation to find the area of a trapezium, which is addition of the parallel lines, which is 18 plus 8. 18 plus 8 divided by 2 multiplied by the perpendicular height. So 2 times 1, 2 times 4, 18 times 8, which is 26, multiplied by 4, 6 times 4, 24, 2 left, 6 times 2, 8, plus 2, 10. So 104 centimeters square. If you have worked out this question by taking this triangle and rectangle separately and adding their areas together, that also fine. You will be getting the same answer, but remember, this is a 2-mark question, right? This is a 2-mark short answer question, which means you have to work out the question with least number of steps, okay? Because you can't waste your time on these kind of small questions, right? So to this, I'm going to revise the whole area thing with you, right? Because we need it in our next step. I will give you all the equations that you need inside your O-level syllabus. Maybe you know them already. If you don't know, not this time. Okay. First of all, we have square. All the 4 sides are equal. If one side is A, area equals length into breadth, which means A times A. Then we have rectangles. Area equals length into breadth. Then we have triangle. This is H. This is B. So the area equals half into base into height. So that's the area. And then we have the parallelogram. If this length is L and this is H, so we can write area equals length into height. It should be the perpendicular height. Here also it is the perpendicular height. Then we have the trapezium. These two are parallel. So if this is A, B, and this is H, we can write area equals addition of the parallel lines, which means A plus B divided by 2 multiplied by H. Sometimes you might be writing it in this way also. Half into A plus B into H. Instead of writing the division 2 in this way, you might be writing in this way also. That also correct, right? That also correct. It's not wrong. So then we have the circle. So the area of this circle is pi r square, which means if the radius is r. Then we have the sector. If this angle is theta, this is r, we can find the area of it. Area equals theta over 360 into pi r square. So these are the equations that you need to know inside the O-level syllabus. So these kind of area questions will be asked from you inside the paper. So I will give you 2-3 seconds. Quickly copy this down. This is the whole thing you need. Right, I think the time is enough. Right, what about the area of the cylinder and cone? Okay, actually, those are solids, right? Here we are talking about 2D figures. Okay, these are not like 3D objects, these are 2D objects, right? So that is a different part, right? So these are like 2D object, as I told you. So if you are thinking about the cylinder and the cone, and also you have the sphere, right? The solid objects that you have to learn in your O-level syllabus is cube, cuboid, and then the pyramid, cone, cylinder, triangular prism, and the sphere, right? If I tell according to your textbook, you are learning cube and cuboid in grade 8 and 9, and grade 10 you are learning about cylinder and the triangular prism, and grade 11 you are learning about pyramid, cone, sphere, right? So those are the objects that you are learning, 3D objects, right? The solids that you are learning, and there you are learning the volume of those solids and also the surface area, right? When it comes to the solids, you have a surface area, but actually it's pretty much easy, right? So you have asked me how to find the area of a cylinder. So I can teach you it in a very simple way. So I will show you. This is a cylinder. Okay, it's just a paper. So I can show you a cylinder in this, right? So this is a cylinder, you can see, right? So the surface area of the cylinder we can discuss in this. What is the surface area first? Let's discuss about that. Surface area means the area that we can touch, right? So in this cylinder I can touch this part, right? I can't take my hand out because this is just a paper. So I can, here I have a perfect cylinder. Okay, so forget about this one. This is a uniformly distributed to a 3D object, a cylinder. So I can touch this part, right? This is a surface area that I can touch. Then I have this bottom. Then also I have this top, but now this is not uniformly distributed. If it is a uniformly distributed, you know, I hope you have an idea on cylinder, right? So if we think about the surface area, right? So in this cylinder, we have three parts which we can touch. First part is this top, second one bottom, then this one, right? The curved surface area, right? This circle, top circle, bottom circle, and then this curved surface area. Okay, so you know how to find it. So if we are going to find the total surface area of this cylinder, we have to find the area of the top circle, then we have to find the area of the bottom circle, then you know how to find the area of a circle. Here you have area of a circle, right? Then what you have to do is find the area of this top circle. It's the same as the bottom circle. So after you find the top one, you can multiply it by 2. Then the problem is this curved surface area, right? This curve is the problem. Now we can memorize it in this way, right? Think about this. So in this cylinder, right? In this cylinder, this part, right? This part is representing the circumference of the circle. This part is representing the circumference of the circle, right? And this is the height of the cylinder. This is the height of the cylinder, and this part is representing the circumference of the circle. So now if I cut this cylinder like this, if I'm going to cut this cylinder like this way, and I open it, right? That circle is going to become the length. See, now I have a rectangle. That circle became a rectangle. See, this curved surface area became a rectangle when I cut it in this way and opened it, right? So this is the surface area that I have touched earlier, right? So when I again rolled it, it's in this way. So this is the surface area that I have touched. So when I'm again going to open it, so you can see it's this part that I have touched. Okay. So this is a rectangle. You know how to find the area of a rectangle. It's there, right? So in order to find that area of that rectangle, you have to find the circumference of the circle and then the perpendicular height of the cylinder. It's the same as the triangular prism. So if you take a triangular prism, this is a triangular prism, right? This triangular prism has 1, 2, 3, 4, 5 sides, right? From these 5 sides, this side and this side, then we can use this method for 3D objects. Yes, but not all. That's what I'm explaining, right? I'm explaining the grade 10 ones. Obviously, cube and cuboid, you can use that method because cube has been made with squares, cuboid with rectangles plus squares, right? Then cylinder, I told you, cylinder is in grade 10. Then this is again in grade 10, this is a triangular prism. So this one also we can find by using these steps, right? This is a triangle. You know how to find the area of this. You know how to find the area of this. This is a rectangle. You know how to find the area of this. And you have all 3 sides in here, right? So what you have to do is after you find all the areas, you have to add them together you get the total surface area. Okay, but there is a problem when it comes to the, in pyramid also we can do the same thing. You have 4 triangles and 1 spare base, but for cone and for the sphere, you have to memorize it, because for the cone, we can't find it in that. Okay, it's not a shape that we are familiar with, that curve thing, that party hat thing. So it's not a familiar shape. When we open it, like cylinder, when we open it, it won't become a rectangle or any other known shape. So that you have to memorize, and then sphere also you have to memorize. Okay, so I haven't added that part to here because actually those are surface areas, right? These are the areas of 2D objects that you have to memorize. So it's really good that you have mentioned it in here. So I hope you have the answer. But remember, you can find, you have like 7 solid objects. From those 7, you can't find only 2. With these things, you can't find the cone and the sphere. Remember that you have to memorize. Okay. Right. Then the 6th question. It says, I will come to that part, that volume 1. I will come to that volume 1 when I am talking about the volume. I'm going to do the same thing with the volume. Okay. So don't worry, in there I will mention you with the those surface area also. Okay. Okay. 6th question. With a liter of petrol, a car can travel an average distance of 12 kilometers. Accordingly, find the distance it can travel using 18 liters of petrol. So for 1 liter, it can travel 12 kilometers. So 18 liters, we have to multiply 12 by 18. So the 6th question, total distance. Total distance equals 18 multiplied by 12. 12 times 8, 96. 9 left, 12 times 1, 12. Plus 9 is 21 kilometers. So 216 kilometers is the answer. That's the total distance. So that's it for the 6th question. And then I'm moving into the essay questions. Right. So question number 1. The question says the figure given shows a doormat consists of a darker area and a lighter area. Before I explain this, I have to tell you, right? From these measurements, from this part that we are discussing today, you are going to get actually 2 questions, mainly 2 questions. One is about area, the other one is about volume. So when it comes to the area, sometimes in one area question you have to use only these. They are not asking about the curved surface areas or the surface areas of the solids. Okay, so that's in there. In there you have to use these equations. Okay, these formulas. Okay. Inside the volume question, sometimes they can ask about surface areas also, right? So I will tell you again, there are 2 questions. One is area. That area question is from this one, right? Only these things you get to that area question. And there's another volume question. In there, sometimes that volume is about solids. No? So in there, sometimes they might ask about the surface areas, right? So now, as the first question, we are discussing a normal area questions that you can get, which means a question from this. Okay, a question from this, right? So the question says the figure given shows a doormat consists of a darker area and a lighter area. The radius of the inner darker part is 49 centimeters, whereas the outer lighter part is 63 centimeters. So, question number 1. I have two circles. This is the darker area. And the radius of the lighter area is 63 and the darker area is 49. That's the total distance. Okay, this is 49, this is 63. So Roman number 1. Under the Roman number 1, it's asking find the area of the lighter part. So which means we have to find the area of this part. Does anyone has any idea how to work it out? It's the same thing as the question that we did over here. Yes, okay, Kishore. Yeah. So now the problem is I can't ask. Yes, pi r squared. Exactly. Right. So we can use pi r squared equation to this circle so that we can find the area of this. Okay. So there are two ways to work out this question. One method is that lighter area and the dark area. Okay. So first I can find the area of this whole circle, big circle. Then I can find the area of this small one. Then I can subtract the small one from the bigger. Okay. That's something I can do. So first I'm going to find area of the light circle. That I can find by using pi r square. Pi r square. Now the and it's just 22/7. I'm not going to replace it because still this is not my final answer. So r is 63, so it is 63 square. Then area of the darker circle, area of the darker circle is equals pi r square. Again, I can write as pi times is 49 square. Now this is the area of this big circle. This is the area of this small part. Now I can find area of the lighter part. Area of the lighter part, which means only this part, right? So I have found the whole thing first, then the small part. What I'm going to do is subtract. So I'm going to subtract this big thing. Big is this. So pi multiplied by 63 square, take away pi multiplied by 49 square. Now I take pi out, so I get pi. When I get pi out, I have 63 square, take away 49 square. Now, this is why I finished algebra before we come to these measurements. Okay, so now here we have to use the factorization. I taught you this. I think the week before, last week I think we did probability and statistics. Sorry, statistics only. So before that I did algebra. So here we can factorize this. This is a difference of two squares. 63 square take away 49 square. So what I am going to do is I have pi, which means 22/7. I can write this as 63 take away 49. Then 63 plus 49. So likewise, I can factorize it. Then I have 20 over 7 multiplied by 63, take away 49. So now 13 take away 9. 14 multiplied by 63 plus 49. 2, 11, 112. So 7 times 1, 7 times 2. I have multiplied 22, 2 and 112. So that gives me the answer. I hope you can see that part of the code. Yeah, you can. Right. So 22 times 2 is 44. So 44 times 112 is equals 4,922. 4,922 centimeters square. Quickly write it. While you are writing, if you have any doubts, you can ask me, because here I did a factorization also. Right. Then let's move into the next part. Right. Then Roman number 2 is asking, if 10,000 rupees were spent as the cost in making the lighter part, find the cost in making 1 square centimeter of the lighter part to the nearest root. So 10,000 rupees was spent. That's what it says. If 10,000 rupees were sent, as the cost in making the lighter part, which means to make this area, to make this lighter area, the cost is 10,000. Exactly. Actually, Kishore, it should be the other way around. We have to divide 10,000 by 4,928, right? Because we have to find. They are asking, find the cost in making 1 centimeter square of the lighter part to the nearest root. So, in order to make 4,928, I'm using this, that what we call the I can't remember the lesson name. Proportions, yes. I'm using the direct proportions. So to make 4,928 centimeters square into 10,000. Why? This 4,928 centimeters square means this one, right? This lighter part. So that costs 10,000 rupees. And they are asking from us, what would be the amount to make 1 centimeter square? So we have to use the cross multiplication and then you can see x is equals 10,000 divided by 4,928, and they are asking to the nearest rupee. We have to find it to the nearest rupee. So actually you don't have to divide it that much, right? Since we are not using the calculators also, we don't have to divide it that much. You can see clearly it's 4,928 if I multiply it by 2. 4,928 by 2, 2 times 8 is 16, 1 left, 2 times 2, 4, plus 1, 5, times 9, 18, 1 left, 2 times 4, 8, plus 1 is 9. So this is the maximum we can go. So to the nearest number, it is 2 rupees. You get 2 point something. We get, when we divide, we get 2 point something. Okay. But the question is asking from us to the nearest rupee. So why do I bother with the decimals? Right? Anyhow, after you find it with the decimal, I have rounded. If you didn't round it, you don't get any marks. Right? Because they are asking you to round it. So what we have to do is show this step and try to find a step. That's it. Okay. So don't go to divide this into decimals, because at the end you have to again round it to the nearest number. So straight away round it and get the answer. So to the nearest as a nearest number, this 4,928 goes to the 10,000 only 2 times. We can't get 3 because if we get 3, exceed the 10,000. Right? So answer is 2 rupees. So to create 1 centimeter square in this light apart, cost 2 rupees. Then next part. A hotel manager is hoping to make a design in his hotel entrance floor. So to do that, he allocated a square-shaped area of 6.3504 meters square to his what? A hotel manager is hoping to make a design in his hotel room entrance floor. So to do that, he allocated a square-shaped area of 6.3504 meters square to his decorative staff. He insisted his staff not to overlap the doormat in making the design. So he has a square-shaped area. That square-shaped area is 6.3504 meters square. And he wants to decorate that area with these doormats. Okay. So they are asking that the hotel owner, the hotel manager is asking his staff not to do overlaps. So you can't keep one carpet on top of another. Right? There's no overlap. And then Roman number 3. Let's go to Roman number 3. It's asking, using the division method, find a square root. Using the division method, finding a square root, find the length of a side of a square area. Okay, we have to find the length of the square area. Roman number 3. So we have a square and its area is 6.3504 meters square. This is a model question, student. This is a model question that I gave to you. This is for the past paper question. So I just want to revise you this division method also, because it is a hidden lesson in your syllabus. 6.3504 meters square. That is the area of this square, right? Sometimes you can get a division method question your first paper, but not most of the time. You don't get it in the second paper. You can get it as a short question. It's a possible thing, right? So now, who knows how to do the division method when you are finding the square root? Who can remember? Anyone? Great, no one. Okay, right. So I think this part might be enough. Let's put this a bit up. Right, I'm going to start it in here. So this is what we do in division method. We have the number 6.3504. What I have to do is, before the decimal point, I have to take the digits as pairs. After the decimal point, I have to take the digit as pairs. Okay, but before the decimal point, I have only one digit, so I can just take it, right? But after the decimal point, I have 4 digits, so I'm going to take 3504. Right? That's how I separate them into pairs. Now let's start division. So I have 6.3504. I start with the division. First, what I have to do is I have to check what is the nearest smallest square number. It should be the nearest, but it shouldn't be greater than this. It should be less than this. We have to check what is the nearest square number to this. It is 4. So to get 4, I have to multiply 2 times 2. So that is the method. That is how we check. This is a method. Right? So there are no reasons why we do that, because it is a method. Right? In this way, we can find the square. Right? So first, I have to find what is the nearest square number to the first number, or the first pair. In here, in this case, I have only one number. So if you have a pair, you have to find the nearest square number to that pair. So in this case, it is 4. So I'm writing 2 and 2 on top. Then 2 times 2, 4. 6 take away 4 is 2. Now after that, I bring down this 35. But remember, students, before I bring down that, I have to put the decimal point. It's normal division. Before I got the 35, I have the decimal point. So I have to put the decimal point and bring down the other pair. Now I have 235. Now what I have to do is, whatever the number left with left in the quotient means the number you have over here. Right? That's the quotient. That's the quotient. And so whatever the number in the quotient, we have to multiply it by 2. So 2 times 2 is 4. And there's a space. There's a space. Okay. Now what I have to do is, I have to fill this space. And when I'm filling this space, I have to multiply the number I get by the number I'm going to put. For an example, if I put 1, I have to multiply 41 by 1. Then I have to check whether I get 235. If I put 2, I have to take 42 multiplied by 2, and I have to check whether I get 235. If I put 3, I have to multiply 43 by 3, then I have to check whether I get 235. It's normal division, right? The only thing is we have to do several things over here. We can't take more. Obviously, it will be less than and the nearest for this 235. Exactly, 5, right? So when we put 5, right? When we put 5, we can multiply 45 by 5. 45 by 5, 5 times 5, 25, 2 left, 5 times 4, 20 plus 2, 25. Wow. Sorry. 5 times 4, 20, 20 plus 2, 20. It's 225. So that is the nearest. So I put 5. 45 times 5 is 225. It is the nearest and less than 235. So I can take it. If I put 5, here I have to put 5. Because then only I can multiply this. 45 times 5 is 225. There's 10 left. Now bring down this 0 and 4. Now, multiply whatever the quotient you have. You don't think about the decimal point, you just multiply it. You have 25 in the quotient. 25 multiplied by 2 is 50. I have to fill a blank. And when I'm going to fill that blank, I have to multiply that whole thing with that number. For an example, if I put 1, that creates a 501. So 500 times 1 is 501. I have 1004, right? So I can go more. So I can put 2. So 502 times 2 is 1004. Exactly. We multiply the quotient only by 2, right? We call it quotient, students. Quotient, it's QUO, quotient. So we multiply the quotient by 2 only. We always multiply the quotient by 2. Okay. So then we fill this blank. Then 502 times 2 gives me 1004, which is 0. So answer is 2.52. So I don't have enough space. So I'm going to write it over here. Our answer is 2.52 meters. That's the side length of this square. Okay, last question, part 4. Part 4, it's asking, roughly draw and show how the hotel manager sees when the design is made in the floor. So we have to roughly draw it. So it's a square shaped space. So, and side length is 2.5 meters. 2.52 meters. And here 2.52 meters. And then we have to check how many circles we can have. It's 2.52 meters. So this whole circle has 63 centimeters. Okay, let's convert this in centimeters because the circle was in centimeters. So this is 252 and this is 252 centimeters. Right? Then we have to check how many 63 goes into that, right? Because the highest length of a circle, sorry, the radii of the total one is 63. So 63 means 63 times 2. We have to check 63 times 2. Why I'm checking 63 times 2? Because I don't have any space. Let me go ahead and write. I'm going to erase this. I don't need it. I might be needing this area. So this is the doormat that we have used, and this length is 63 centimeters. Okay, which means the total is 63 times 2. Total, the diameter is 63 times 2, which means 6, 12. So I can put one circle like this. I can put one circle like this. I don't know. I just put it. Right. So here this total length. This total length is 126. Then I have to check how whether I can put another circle over here to become 252. So 126 times 2 is 12. 2 times 2, 4, 5. 2 times 1, 252. Yes. I can put another circle also in this. How did I find that? The diameter is 126. So I can put 2 diameters inside this square shape. So I can't do overlapping. So I didn't do any overlapping. And to this side also I can put another circle. To this side also I can put another circle. So you get 4 circles inside the square. So you can draw it properly by using a compass. Right, so you don't have to use a compass, it says roughly draw it. So you can just draw it and show that this is 120, the diameter is 126. That's it. This is the center, 126 centimeters. So this is how we roughly draw it. I hope you get it. Roshini, now only I saw your message. No, Kishore, you have to show the measurements in there. You have to show the measurements in there because it is a must. Okay. Because in a rough circle, you have to show it. Sorry, in a rough scale, in a rough diagram, you have to show the measurements. That's why we call it a rough diagram. Because if you draw proper diagram, you can just use your rulers and compass and everything to draw proper. Right. So since you do a rough one, you have to show what are the lengths and all the parameters that you need to show that you have taken. Right. So you have to show those parameters. Roshini, which question you want? I can go back if I haven't erased this. Now only I saw the message. Roshini, are you there? I think no. Yes. Roshini is there. Right. If you have any doubt, ask me now. When I saw the messages, I replied to you. If I didn't reply to you, means that I didn't see the message. Okay. Then let's move into the second one, right? Right. Let's go to the second one. Now it's a past paper question. This is the question that we just did. It's a module paper question. Now we are doing a past paper question, and this is about volume. Okay. So students, when it comes to the volume, there are going to be two types. Okay. One type is melting something, and we are going to create another thing. Okay. So there are mainly like famous two types. I think this time also you might get a question from those two types. Okay. So those two types are like this. So we are talking about now solids. There are 5 solids. I will explain that to you. When it comes to the volume question, there are two famous types. First type is melting one solid, and then by using those things, those melted stuffs, we are going to create another new solid or more than one solid. We are going to melt something without any wastage. We are going to create new things. Okay, that is one type. The other type is the Archimedes theorem. Does anyone know the Archimedes theorem? Anyone? Archimedes theorem. When I say eureka, eureka, does it ring any bells? No. 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 Seriously, you haven't heard that story? It's very famous though. I have very little time. Without any more narrations, I will just tell you the story in a brief. So Archimedes is a mathematician, right? So he was thinking about measuring objects. Measuring objects, I mean like using the densities, right? So you know there is an equation on the science. In science, you have is it B equals M over V? I can't remember. I did my O-levels in 2009. I think this is the equation. Density equal mass over volume. Yes. Have you heard about this? No. Yes. Okay. So so actually he invented, he used this equation. Okay, so this is about water displacement. You learn this in science, right? He's the person who explained about this for the first time to the whole world. Okay, how he found it out? He was going to take a bath, right? I hope now you can remember the story. He was going to have a bath because, like, not like in nowadays, they don't have showers or anything. So they just have a basin and they are going to, it's just like a tub, right? They don't have any water supplies like in nowadays. They just going inside the tub, right? To have a bath. When he is going inside, when he's going inside the tub, just some amount of water came out, right? When he is looking at that, suddenly he got understood, right? So the water came out because he went in, right? So water came out because he went in. So from there onwards, he did some calculations and proved that the amount you put inside the submerged, the volume of the submerged particles is equals to the volume of the displacement, right? And the funny part is actually, as I told you, he found this when he's going to have a bath, and since he's going to have a bath, so he found it when he's going to have a bath. After he found it, without overwhelming happiness, he just ran to the streets without any clothes by shouting "Eureka, Eureka," which means in English, "I found it, I found it." Right, that's the story. It's real one. It's real one. It's a very pretty famous one. And I hope you have heard the word Eureka. That's I found, right? So that was more popular because of that story. And there was king story also involvement to that. He is measuring a crown of the king, right? It's like very lengthy one. So the nice short story is Archimedes ran naked on the street. The story in nutshell, right? And he's the person who found it. Pythagoras, not Pythagoras, Archimedes Theorem, right? What Archimedes Theorem says: when you submerge something, when you put something inside water, that water level comes up, right? That's what he found. And when you put something inside the water, that volume of that thing is equal to the amount of water volume which comes up. That's the Archimedes theorem, and since it is related to volume, you have to work out those kind of volume equations also. So that is the second type, right? So I have included both types inside this paper. So let's discuss, right? Before I discuss, I have to tell you, one of you asked how to find those volumes, right? What are the equations for those volumes? What are the equations for those solids when we are going to find the volumes of those solids? Actually, you don't need to worry, right? If you are referring past papers, you can see at the beginning of the past paper, they are giving you all the volume equation that you need to do, that you need to use inside the paper itself, right? So for an example, if you have a past paper book now, you can just go and check inside the instructions. Inside the instructions, they are giving you the required equations, but then they are giving you that only in the second paper, right? They are not giving you that in the first paper, so it's in the second paper. So they are giving you that equation. Okay, so you don't have to worry about those equations that much. So actually, yeah, they are giving it. So you don't have to memorize it. So they are not giving all the equations. They are just going to give you the required equation that you need to solve the question inside the paper, right? If it is about cylinder, they are going to give you the volume of the cylinder, the equation of the volume of the cylinder. If it is triangular prism, they give it. Okay, so you don't have to worry about, they give the equation in there itself. So I'm not going to give you that all the equations. So let's do the question. Otherwise, again, today also we have to do until 10 o'clock. Right. Second one. That question says the radius of a solid right circular cylinder is r and its height is 2. So the Roman number 1, it says write down total surface area of the cylinder in terms of r and simplify it. So this is the surface area question, right? Okay, I told you that I'm going to give you all the things that you need. So I will give it to you now. No, I will do this. I will do this question. Otherwise, we won't be getting enough time. If we get time, I will give you at the end of the class, or else I will give you a printed one. Typed one into our group. Right? I will send it to the groups, so you can take it from there. Otherwise, it's useless. No, just wasting our time. So let's go to the question. It says the radius of a solid right circular cylinder is r and its height is 2r. Roman number 1, write down the total surface area of the cylinder in terms of r and height. So we have to find the total surface area. So as I mentioned, we can find the total surface area of a cylinder by using the way that I told you just now, right? So this is a cylinder. If this is a cylinder, if we are going to find the total surface area, we have to find the area of this side, and the area of this curved surface part. Okay, so that is what we have to find. So I gave you the equation how to find the area of the circle. So let's use it. And before that, I'm going to draw a small diagram with the given information. We have the cylinder and the radius is r and the height is 2r. So total surface area. Total surface area, because actually you have an equation in your textbook, you don't have to memorize it, right? Why do we memorize extra stuff when we have a lot of things to memorize, right? So you don't have to memorize it. What you have to do is you can find them separately. So first find a circle. So area of a circle is pi r square. Pi r square, since we have two circles on top and bottom, we multiply it by 2, so we have 2 pi r square. Right? Now plus. Now we have to find the surface area of, I will do it in this. We have two circles and a rectangle. That's it. Right? The total surface area of a cylinder we can separate three parts, two circles and the rectangle. Why the rectangle? This is the rectangle, and when I bend it like this, when I roll it like this, it becomes a cylinder. Right? I explained like many times now, so I hope you get it. So now we can find the area of the circle by pi r square. Radius is same in top and bottom both, pi r square. R. Now we have to find the area of this rectangle. So now this is a model one. This is a model one. This is the rectangle that I have drawn in here. So I get the cylinder when I roll it in this way. When I roll it in this way, I get that cylinder. Right? So this is how I get the cylinder. Now, when when I open it, it becomes like this. So I have to find the length and breadth in order to find the area of this rectangle. So let's find what is this length. Length is this part. So check what happens when I'm going to roll it. Check what happens when I'm going to roll it. Right? That length has become this circle. That length has become this circle. Okay? Which means if I found the length of this circle, which means the circumference in other words, then I can find the length of this rectangle. So how do we find the circumference of a circle? 2 pi r. That's the equation, right? Circumference of the circle is equal to 2 pi r. And then let's say this is the rectangle. When I roll it, it becomes like this. When I roll it, it becomes like this. Now breadth becomes the height of the cylinder. See, breadth becomes the height. Okay, so the height is 2r. So I have to do plus 2r. So this is how we find the total surface area of a cylinder. So you can see, obviously you can't memorize this, right? So here we have taken a normal cylinder. We can't memorize, this is very lengthy, right? So we can simplify it in this way. Pi r squared plus pi r squared is 2 pi r squared plus, I can take this one. Oh, sorry, what I have done in here, it's multiplication, sorry students, it's multiplication. Why? Length is 2 pi r, length is 2 pi r, breadth is 2r. Because here the height is given 2r. So in order to find the area, 2 pi r into 2r, which I get 2 times 2, 4 pi r squared. So altogether, 2 pi r squared, 4 pi r squared, it makes 6 pi r squared. That's the total surface area according to this question, right? When they gives us different one, we get different ones, right? So normally, so that should be height, right? Yes, 2r is the height. 2r is the height because this is the rectangle. When I roll it like this breadth is the height of the cylinder. See, that breadth becomes the height. So it's the same as the height, right? So in this rectangle, the length is the circumference of the circle, breadth is the height. So 2 pi r into what? 2 times 2 is 4. Pi r times r is pi r squared. So it is 6 pi r squared. Then question number 1, A1. Then A2. Question number A, Roman number 2. If the cost of painting the surface area of the cylinder at the rate of 1 rupee per square unit is 24.5 rupees, find the value of R. So for 1 square unit, it takes 1 rupee. So to do this whole thing, to paint this whole cylinder, it took 24.5 rupees. It took 24.5 rupees, which means to paint this whole thing, it took 24.5 rupees, right? Yes, 24.5. So total cost of painting we can find. Here we have 6 pi r squared, and then we can find total for painting. So to paint one unit, it costs 1 rupee. So to paint 6 pi r squared unit, how much rupees it would take? I'm just doing this step just to give you the best understanding. Otherwise, you don't have to do it like this, right? To do 1 unit, right? We don't have any measurements. These are units. These are the things. To do 1 unit means 1 cubic centimeter, or 1 square centimeter, or 1 square meter, or 1 square millimeter. We don't know. To do 1 unit, it takes 1 rupee. So we have altogether 6 pi r square unit. Then how much will it take? So we just have to multiply it into this side, x times 1 plus x. So x is equals 6 pi r square. So to pay this whole thing, it takes 6 pi r square rupees. And they have given, it took 24 pi rupees to pay this whole thing. So we know it should take 6 pi r square, and they have given it is 24 pi. Also in that, they have given in another, the same amount they have given in other. So this amount and that amount is equal. That amount means that 24 pi. So they can write 6 pi r square is equals 24 pi. Why? 6 pi r square means the total amount that we need to spend to paint the cylinder. And in the question itself, again, they have given to paint this whole cylinder, it costs 24 pi rupees, which means these two are equal. This is something we have found. This is something that they have given, right? So these two are equal. Now, what I have to do is I can cancel it, divide it by pi. No, just straight away, just divide by 6 pi. This side, 6 pi. 6 pi get cancelled off, pi and pi get cancelled off. 6 times 1, 6 times 4. Now r square equals 4. Take the square root, take the square root. R is equals 2 centimeters. Oh, sorry, not centimeters. 2 units. We don't know what. So they are asking us to find the radius. Radius is 2 units. Right, that's the end of the first part. Right. Then let's go to the part B. This is the surface area question. This is surface area question that you can get. Right. So likewise, they can ask from triangular prism, they can ask from cone, they can ask from sphere, square-based pyramid, anything. They don't ask from cube and cuboid because it is grade 9, 8, 9 question. So these are things you have to prepare for on total surface area. So you can clearly see this is different from the thing. So you can clearly see that there is a very big difference from the first question and the second question. The first question is from the areas that we have learned, that by using the whole equation that I gave in this side, right? So this is completely different. This is surface area of solids, right? This is completely different. Those are the previous question is from 2D objects. This is from 3D objects. Okay, right. Now the next question B. The question says a right circular solid cylinder of radius r and height h. It's a separate question. Now there's something to this. So we have drawn different shape. Sorry, different figure. And now the radius is r. The radius is r and the height is h. Melted and 12 equal solid spheres of radius 8 were made without any base of metal. And they are going to make 8 metal spheres. So how to draw a sphere? You draw it something like this. So I'm not wasting my time to draw a sphere. It's a sphere, right? That's a sphere. So here the radius is r. Right. Now they are going to make this cylinder. They are going to melt this cylinder, and after that, without any wastage, which means we have this whole volume that we had over here, and they are going to create 8 these kind of balls. Right? Sphere means balls, no? So sorry, not 8, 12. They are going to make 12 of these. Right? So now the logic in here is when you are going to melt this and create 12 of these, right? The volume you had over here is equal to the volume of 12 times this, because you melt this and we create 12 of these, right? So the whole volume we had here divided into 12 equal parts in these kind of objects, right? So what I have to do is, so they are asking, they are going to make 12 equal solid spheres of radius A or radius A were made without any waste of metal. Show that A cube is R squared H divided by 16. So now this is very easy, right? Whatever the question, if you get a melting question, this is what you have to do. They are going to make this and create this, and they are going to ask you to show the relationship between these, relationship between the parameters of this. Parameters means the radius, height, blah blah blah, and we have to show the relationship between the parameters of this cylinder and this sphere, right? So you can see in the equation that they are asking us to show, you have A and R both, which means we have to make a connection between these two objects. So how to make the connection? They are going to make this and create 12 of these. So what we have to do is, first we have to find the volume of this cylinder, and then we have to find volume of 12 of these, and then we can make them equal to each other. Why? If we don't have any wastage, the total volume we have over here are there in 12 of these kind of spheres. If you don't understand that logic, tell me. If you understand that logic, then you can solve any question, right? You can solve any question. What you have to do is separately find the volumes of these, right? So first I'm going to find the volume of the cylinder. We can find the volume of the cylinder. If it is a student, now I will easily tell you, I will tell you a method how to memorize these volume equations easily. If it is a, what do we call, equally distributed object or a solid, then it is easy to find the volume, right? So we call it the uniformly distributed object, right? So this cylinder is a uniformly distributed object. So if I take this, I'm going to take a cross section area, right? How I take a cross section area from this cylinder? I'm going to cut it in this way. So if I cut the cylinder in this way, everywhere I get circles, right? And those circles are equal in size also, right? If it is a uniformly distributed object, when I get the cross-section areas, all the cross-section areas are equal in size. If it is not uniformly distributed, then the cross-section areas are not equal to each other. We don't use this method. If it is a uniformly object, only you can use it. So what kind of objects you can use? Cylinder and the triangular prism only, right? I told you are finding cube and cuboid, definitely can. But apart from that, cylinder and triangular prism, right? Which means grade 10 volume lesson, right? In grade 11 volume lesson, you have different cross-section areas. When you take a pyramid, when you cut in this way, yes, you get squares, but they are not in equal size, right? If you take a cone like party hat, you can take cross-section areas, you get circles, but it's not equal in size, right? So remember that. So volume of the cylinder, how do we find? Cross-section area in height, right? So what I'm going to do is, I get same cross-section area. So from that same cross-section area, first I'm going to find that cross-section area and multiply it with the height of this. So the cross-section area is pi r squared in here. That's the cross-section area. It's a circle. And then I'm going to multiply it by height. So it is pi r squared. Very simple. And this is the equation to the volume of a cylinder, right? This is how you find the volume of a cylinder, and this is the equation that they have mentioned in your textbook also. Then let's go to the sphere. So volume of a sphere. Volume of a sphere that they are going to make in here is, now sphere is not a uniformly distributed object, so you can't use your general knowledge to solve it. So definitely you have to use the equation. So we can find the volume of a sphere by using 4 over 3 pi a cube. A is the radius, right? Since it is a volume, it is cube, right? Now we have 12 of these. We have 12 of these. Now what I'm going to do is this volume is equals to 12 of these. That's the question says to us, right? So that the volume of this, which is pi r squared h, is equal to 12 times this amount. So I can write volume of the, this is the logic part. It's better if you can write this in your paper itself, so the person marking paper knows that you have very good understanding. So volume of the cylinder is equals 12 times volume of a sphere. Why? They made this and they create 12 of these, right? I said it like now 100 times. Okay, so now let's make them equal. So we have pi r squared here, pi r squared h equals, this side we have 12 times 4 over 3 pi a cube. So 3 times 1, 3 times 4. Now this side pi and this side pi can be cancelled off. Why? I can divide this side by pi, this side by pi, so pi and pi get cancelled off. So I left with r squared h equals 4 times 4, 16 a cube. Now look at the answer. After you take this part, this much, look at the answer. Right? They have given you an equation to show. So you have to show that. You can't just work it out by yourself. You have to get that and check. So the equation given a cube is equals r squared h over 16. So if it's equal, what you have to do is divide this one by 16 so that you can get a cube is equals r squared h over 16. So we get a cube equals r squared h over 16. You have to write it in the normal way, in this way, the way that they are asking from us. Don't leave that answer in like that. So you have to write it in this way. So this is the volume question, the first time, right? The part 1, melting time. This is how we made it. Melting time volume question. Then the third one. So write it because I'm going to erase the whole one. I hope you are done with this part. Okay, I think the time is enough. Right. Let's go to the third question. Third question says a right circular cylinder vessel with internal base radius 7 centimeters and height 15 centimeters is filled with water up to height of 10 centimeters. Calculate the volume of the water. So let's straight away draw a diagram first. Here we don't have a diagram. So the very first thing that we should do is drawing a diagram. So we have cylinder. And the radius of this cylinder is 7 centimeters. And the height of this cylinder is 15. And the water has been filled up to 10. So we have water inside of this, and that is 10 centimeters. So I have represented all the data that needed. Then they are asking calculate the volume of the water. So it's very easy. Volume of the water, volume of the water is equal. This water is in a cylindrical shape. So it's inside a cylinder. So we have a cylindrical shape. So to calculate the volume, since it is a cylinder shape, I taught you how to calculate the volume. It's cross-section area into height, because this is a uniformly distributed object. So the cross-section area of the cylinder is pi r squared into height. Sorry, the cross-section is pi r squared. So first I'm going to write the equation. It's pi r squared into height. So pi is 22 over 7. Now the radius of this cylinder is 7. So it is 7 times 7 multiplied by h. Now don't put this h. This is the height of the total cylinder. We are not calculating the total height of the cylinder. We are calculating the water volume only. So we have to take water height only. So it is 10. So 7 and 7 get cancelled off. 7 times 2 is 14. 154 times 10. Yes, your answer is correct. I didn't show the name. I didn't see the name. Someone was just put it in the chat. It's 1540 centimeters, not squared. It's a volume. So cube. Right? Be careful with the units. If your units are wrong, you are going to lose 1 mark. Then question number B. When 18 small solid metal spheres of radius a centimeters are put into a bow vessel, its water level goes up by h. So to that, I'm going to draw a different line. Now let's use the same thing. So now what they are going to do is they are going to put 18 small solids, right? Sorry, 18 small spheres, right? Is it 80? Yeah, they are going to put 18 of them. Yes, 18, right? 18 small solid metal spheres of radius a centimeters put into the above. Now, 18 of small spheres going to put inside this vessel. So now, Archimedes Theorem. What happens when you put something inside the water? That water level comes up, right? The volume you submerge is equal to the volume of the displacement, right? So what I'm going to do is, now the water level has risen 8 centimeters. Earlier it was 10. Now it is 8 centimeters. So because the question says its water level goes up by 8. So water level comes up by 8. So now I have to find the new volume, right? No, not new volume. What Archimedes theorem says, the displacement of the fluid is equal to the volume you submerge, right? ඒ කියන්නේ අපි ගිල්වපු එකේ තියෙන volume එක equal වෙනවා එළියට ආපු volume එකට. කියන්නේ උඩට ආපු volume. submerge කියන්නේ ගිල්වපු. ඒතර displacement කියන්නේ උඩට ආපු. ඔයාලා සයන්ස් පැත්ත හරියට ඉගෙන ගන්න නැත්නම් ඔය terms ටික පොඩ්ඩක් අමාරු වෙන්න පුළුවන්. The volume of the submerged object කියන්නේ ගිල්ලපු object එකේ volume එක. එතකොට ඒක equal වෙනවා water displacement එක. water displacement එක කියන්නේ උඩට ආපු water level එක. So water displacement is in here. So this volume is equal to 18 small spheres. So that's what it means. So let's find. Volume of the submerged is equal to the volume of the displacement. Right? So always write this logic. So as I told you, so earlier we melted and created new things. Now we submerge things and then water level comes up. So the volume of the submerge. So what are we submerging here? Spheres. So it is 4/3 multiplied by pi, and the radius of a sphere. Radius of a sphere is a centimeters. It's a cube multiplied by, we have 18 of them, so we have to multiply it by 8. Volume, this is volume of one sphere. 4/3 multiplied by 5a cube. Why it is a? In the question it's given the radius of a sphere is 8. We have 18 of them. We are going to submerge 18 of them in here. So that volume is equal to the water level which came up, right? So came up is 8 centimeters. That's the height came up. It's 8 centimeters. So now we can write an expression to that volume. It is in a way of cylinder. It's in that cylindrical object. So that water level comes up as a cylinder. So again we can use the same equation, pi r squared h, which means pi r is still 7. So it's 7 times 7 times water level came up h. That's it. Right? I hope you understand. If you don't understand, you can raise your questions at any time. So what I'm going to do is I'm going to cancel off this pi and pi. So you can see always I never write this 22/7. Previous question also straight away I could cancel off this pi and pi. So don't write it as 22/7 and cancel off these things and take it to the other side. Yeah, explain it again. Okay, Roshi. So I hope you understood this A part. Here I think the problem is in how I use these numbers. I hope that's the problem, because I explained that Archimedes theorem, volume of the submerged objects is equal to the volume of the display. And I think you understand this also. They are telling us in the question they have submerged spheres, 18 spheres, right? So the volume of one sphere is 4/3 pi a cube. Since we are submerging 18 of them, we multiply by 8. Now I think the problem is in here. Why it is 7, 7 and 8. Okay, I will explain. So now this water level came up this much. Water level came up this much. Okay. So I'm going to draw that water level which came up. So inside that cylindrical object, that water level stays like this, right? Think of a water bottle, normal water bottle, right? When the water level comes up, it comes up as a cylinder because the fluid takes the shape of the object which is it in, right? So the fluid takes the same shape of the object. So when it comes up, can we use direct answer for cylinder volume? This, no, you can't use this. This is the whole water level. This answer is the whole water level. If you mean this is the whole water level, water volume. This is the whole water volume inside the cylinder, right? What is Archimedes said? Archimedes said that the volume of the submerged things is equal to the displacement. So how much it displaced? This much. Only this part. This part is the displacement, not this whole thing. Right? ඔයාලට හොයන්න ඕනේ අර උඩට ආපු ටික විතරයි. මේ science කියලා දෙන්නේ මම. This is science, not maths. Right? That volume is not equal to this whole thing. It's equal to only this whole part only. Right? So we have to find the volume of this part, which means this side is h. Okay, මම මේක වෙන බැලුවා. මේ තියෙන්නේ මේ h කියලා දාපු එකම. Right? So this is the part which came up because of these 18 spheres, and the radius of this is 7 because it has the same radius as the cylinder. We can't use this. We never can't use this. The volume of this water, what we have inside the cylinder. Don't get confused. Right? Here we can't use that because this whole water level didn't come up. Right? Only part of it. Only this much came up. Only this much came up. So now, Roshini, I use this one. This is the amount of water which comes up because of that submerged spheres. So we can find the volume of this. How? This is a cylinder. How do we find the volume of the cylinder? Pi r squared h. Why? Cross-section area into height. Cross-section area is a circle. So circle we can find by using pi r squared. So pi r squared means radius into radius. So radius is 7. So pi into 7 into 7. H is the height which water level comes up. So they have given in the question it is h. I hope you understand it now. So we can't use this whole thing. We have to use this only this part. Right? Okay, so we have to simplify this now. 3 and 8 we can cancel out. 3 times 1, 3 times 6. So we have 4 times 6. 4 times 6 is 24. We have 24 a cube equals 7 times 7, 49 h. Now look at the answer. We have h. They have isolated h, which means we have to set 49 to other side. So h equals, it is division 24, 49 a cube. That's what we have to show. I took this 49 to other side by using division. Right? This is very easy. I hope you understand this. Okay, so I covered the both part in the volume which you can get as a question in your level paper. One is this Archimedes theorem, the other one is the melting thing. Okay, then let's go to the last question. And actually this is not related to volume or area. This is related to area, but actually this question is from quadratic equation. I told you in the beginning also. I gave this question because I didn't cover this part. I did quadratic equations and factorization, but I didn't cover this part. This part means that using the completing square method or the equation method, I just did the factorization and graph only. So that's why I'm doing this question now. So let's go to the question. It says the breadth of a thin rectangular metal sheet is x plus 2 units. Its length is twice its breadth. Then the first one, express the length of the sheet in terms of x. So we have to write. Diagram. So it says the breadth is x plus 2. Breadth is x plus 2. Now the length we have to find. Right? They have given that the length is twice as the breadth. So we can find the length is equals twice as the breadth, means 2 times x plus 2. You don't have to simplify this. Right? I told you normally when we are writing our answer, we left it in factorization form, factorized form. Right? So you can just leave it in this way. Then Roman number 2. If the area of the sheet is 12 square units, show that x satisfies the quadratic equation x squared plus 4x minus 2 equals 0. Now we know the length is 2x plus 2 and the breadth is x plus 2 units, and they have given area is. So what I have to do is find the area and check whether I get that quadratic equation. How do you find the area? This is rectangle, length into breadth. So 2x plus 2 multiplied by x plus 2, that is length into breadth, equals, and that area should be equal to 12. Why? In the question they have given area is equals to 12 units. Now let's simplify. Let's simplify this first. X times x, x squared. So 2 x times x, x squared. X times 2 plus 2x. 2 times x plus 2x. Plus 2 times plus 2 plus 4 is equals 12. Now what I'm going to do is I'm going to take these 2 to the other side by using the division. Divide by 2, divide by 2, 2 and 2 get cancelled off. Here I get x squared plus 2x plus 2x is 4x plus 4. 12 divided by 2 is 6. Now I have to take this 6 to the other side. Then x squared plus 4x plus 4 minus 6 equals 0. Plus 4 minus 6 is minus 2 equals to 0. This is what they are asking us to show. Right. So students, if you can stay, I warmly welcome you to stay, because it will take only maximum 5 to 10 minutes. It's not more than that, because I'm also improving myself. When I started, it took like more than 3 hours. So now I'm trying my best to finish it off in 2.5 hours. Because I know it's hard to be in an online class like more than 2.5 hours to 2 hours, right? Maximum 2.5. Okay. Yes. One has given me the answer also. So the third part, that's the part I need to teach you, right? This is very simple. That's the part I need to teach you. Question number 5. Roshini, which question? We don't have 5 now. This one. This Roman number 2. Question number 4, Roman number 1, Roman number 2. Okay, so you mean question number 4? Roshini, you need question number 4. Yeah, in paper 6. Yes, we are discussing paper 6. And we are discussing the question number 4. First page. First page, 5th question. Right, Roshini, it's a trapezium. First page, 5th question is a trapezium. Actually, it's hard to go back. Roshini, I'm really sorry. Because there are other students also. So What I can do is, Roshini, I can send you the this thing, the class recording. I will send you the class recording. We discussed, right? The part one, that in short answer question, question number 5, we discussed it. I will send you the this thing, the class recording. Please send me a message. To that, I will send you the recording. Okay. Otherwise, we can't go back now. I hope you understand. Right. So the last part, third one. Solve the above equation by completing square or by any other method. So now we have to solve this question by using the completing square method. By any other method means we can use factorizations. I don't think we can't use factorization because this is not possible to factorize. Then there is another method called equation method. So today I'm going to teach you the completing square method. Next part, in next time algebra, when we are doing algebra, I will teach you the equation method. Right? So this is what completing square method is. So actually now take a note, right? When it comes to the quadratic equations, which means the equations like ax squared plus bx plus c equals 0, this type of equations. There are 4 methods to simplify these equations, right? First method is factorizing. This I have completed. Second one is graph. In the graph, I taught you how to find the roots. By finding the roots, we can find the solutions for these things. Then the third method is completing square method, which we are going to learn now. Completing square method. And then we have the equation method. And the equation is x equals minus b plus or minus b squared plus, I will write it here, x equals minus b plus or minus b squared minus 4ac square root divided by divided by 2a. This is the equation. I'm not going to do this part today, right? I'm going to complete it later. So now you are okay with factorizing, we graphs also, but we are doing in graphs. We didn't complete, we didn't like cover everything in graphs. Today I'm going to do this completing square method. Then we have to equation only. So just note it down so you have an idea what we did and what we have to study. Okay. Just quickly note this down. This is how we solve quadratic equations. Okay, I hope the time is enough. If you're still writing, raise a hand or just send me a message if you need more time. Yeah, I hope it's fine. Right. I will leave it. For now, I don't need this one. So our equation is x squared plus 4x plus 2 equals 0. So this is how we do the completing square method. To any question, to any quadratic equation, this is the method that you have to follow. First of all, what you have to do is you have to make sure that you don't have any number in front of this x squared term. Sorry. you have to make sure that you don't have any number, which means any coefficients to this x square, right? So now it is a 1. You don't have any other number. If you have a number, before you start this, you have to divide this whole equation by that number. For an example, let's say you have 2. If you have 2, what you have to do is, before do anything, you have to divide each and every term in this equation by 2. So 2 and 2 get cancelled off. 4 divided by 2 is 2. 2 divided by 2 is 1. If it is not divisible, you have to leave it as a fraction. For an example, if you had a 3, you have to divide all the coefficients by 3. Then here you get fractions also. That doesn't matter, right? So you have to leave it as fractions. So remember, if you have a coefficient, first you put that coefficient, right? Then after that, what you have to do is send this constant. You have a number which doesn't have an x over here. So you have to send it to the other side. So I'm sending that 2 to the other side, x squared plus 4x. Sending this 2 to the other side makes minus 2. Now I have x squared term and 4x along in this. Now this is what I do. When you come to this step, there shouldn't be any number in front of this x squared. Remember that, right? Now what we do is we open a bracket and then write whatever the letter we have over here without the square. Sometimes we might have y or z. In this case, we have an x. So we write it without the square. So it is x. Whatever the sign over here, just put it over here. It is plus, so I put plus. Now, don't think about this x. Don't think about this x. Don't think about this x. Okay. Divide this coefficient. Divide the coefficient of x. Coefficient means the number in front of the x. Coefficient of x means the number in front of the x. Coefficient of x squared means the number in front of the x squared. So you have to divide the coefficient by 2. Here, luckily it's divisible. We can divide 4 by 2. But if you have a number like 5, then don't go for the decimal. Just write it over here, 5 divided by 2. 5 over 2 as a fraction. It doesn't matter. Right? So in here, luckily it's divisible. So it is 4 divided by 2. Now put a square. Right? Then, students, 4 divided by 2, straight away I'm writing it in here. 4 divided by 2, the answer is 4 divided by 2, answer is, I don't want to write it as fraction. So just note it down with a pencil or something. How did we get this number? We divided this one by 2. Or you can use a pencil and draw an arrow. We divided this number by 2. Okay. Then you have to put a subtraction mark. It doesn't matter what question you have. You always put a subtraction mark. Then you square this number and put it in here. Square of whatever the number you get. Square of whatever the number you get here. You have 2. Square of that is 4. So square of that number is 4. Then you do minus 4. This is equals to minus 2. Again, I will tell you what we did in here. After we send this constant to the other side, this x square term, we open the bracket. We write this x without this square. Whatever the sign over here, we write it over here. Then divide the coefficient by 2. Then put a square to this bracket. Then minus sign. It's always minus. It's always minus. Then square this number and put it in here. Whatever the sign, it doesn't matter the sign which we have in here. If it is a minus, when we square it, it becomes plus. If it is plus, definitely when we square it, it becomes plus. So whatever the number you have in here, square it and put it here. But remember, in front of it, always a subtraction. Now, what we are doing is sending this minus 4 to the other side. So we have x plus 2 to the power of 2 equals, sending this minus 4 to the other side, it becomes Students, I have made a mistake. In the question here we have a minus. I hope no one didn't notice it. Right? In the question here we have x squared plus 4x minus 2. So when this minus 2 goes to the other side, it becomes a plus 2. Okay? It's a mistake when I'm rewriting the question in here, I guess that. So I have added plus 2, it should be minus 2. When that minus 2 goes there, it becomes plus 2. None is going to change. Right? It's everything looks like this. Only thing is when we send it to the other side, it is plus 2. Now in this step, we are sending minus 4 to the other side. It's become plus 4. So we have x plus 2 squared equals 4 plus 2 is 6. If you have any doubt, you can raise it now. If you have any doubt, you can raise it now. Anyone? Okay, no, that's a green line. Then let's move forward. Now after this, what I'm going to do is I have to find the value of x. So I'm going to first remove this pair. To remove this pair, I'm taking square root in both sides. Remember, when you are taking a square root, you have to put plus or minus. It is a must. Right? I know in Pythagoras relation or any other question, we didn't put that plus or minus thing because in there we are dealing with lengths. Right? A length cannot be minus. Okay? We never tell that we went minus. For an example, let's say you are jogging and after you jog, you don't tell today I jog for minus 3 kilometers. Right? Even you ran backwards. Right? So when we are talking about length, it cannot be minus. That's why in those questions we didn't put this plus or minus sign. But here we put it. Okay, when we take the square root, we put plus or minus. Then square root of a square number gives the same number, x plus 2 equals plus or minus square root 6. Then I'm taking this plus 2 to the other side. So I get x plus 2 goes to the other side, becomes minus 2. Then I have to simplify this. So you can see the question in the question that they have given, square root 6 is equals to 2.45. So that's how I identify that I have made a mistake when I'm working out in here. Because in the question that they have given that about square root 6. But when I have minus 2, I don't get the square root 6. That when I knew that something is wrong. Then again I check from the beginning, then I saw that something is wrong. Right? So just learn those things also. Okay, so in the question they have given the square root 6, but when I'm solving the question in the previous way, I don't get the square root 6. Right? I get something else. That's why I check it again. Then only I notice that there should be a minus sign. Right. So now they are asking us to take square root 6 as 2.45. So we can write this one as plus or minus 2.45 minus 2. So we can rewrite the x value. X can be equals to plus 2.45 take away 2, or x can be equals to minus 2.45 minus 2. Then here the answer is 0.45. Yes, that answer was correct. Whoever the showed, send it to me. The answer is correct. Then minus 2 becomes addition, so it is minus 4.45. Those are the two answers. Yes. It's 9:45. Still I have to practice. See? I hope, like in me, you also are improving. Right now, I can manage, like, at least it's not go beyond 10 o'clock. Right. So students, that is the end of our today's paper. So if Roshini, I don't know whether you had a connection or something. If you have that kind of a thing, you can send me a message because I can't find you in another group, so that I can send you the recordings and the things that you need. So if you are joining to our class for the first day, if this is your first day, you can send me your, so you can say always send me a text, so I can send you the previous papers to you. If you newly join to our groups, then you won't be able to see our previous papers. So send me a message, I will send you the previous papers. And also I did a geometry seminar. It was a free seminar. And in the second cycle also I'm going to do the same seminar when I'm going to the geometries. It's about circle geometries. Last time I did polygon geometries. Now I have to do the circle geometry parts. So that's how I covered. So students, if you stayed with us from the very first day, then yes, we have covered the whole O-level paper one time, right? So again, from the very beginning, again from next week, again, we are going to do it again, right, for the second time. So at the time, what you can do is just don't come to this class and take notes and quick questions. It's not enough. What you have to do is do as much as past papers you can, right? If you are working alone, if you don't have anyone else to ask, you always can send me your doubts. But remember, I have other works also. I'm a teacher also, so I try my best to reply to you. Okay. So if I didn't reply, actually I'm sorry, right? So it's your thing is don't just put one message and just leave, right? Because in a day I get like a lot of things. I'm a school teacher, so I'm teaching in a school, so I'm not on a Skype. So I have their group messages, my university messages, friends, and other classes, lot of messages. And when I go to sleep, only I can check it. So if you didn't trouble me enough, then I won't be seeing it, right? So it's not a trouble to me. So always, if I didn't reply to you, just send it again. Just send it again, right? So then I can, when I notice it, I will send it. I will give you the answers. Okay. Actually, it's not trouble to me. I'm not going to scold you why you are troubling me like that. It doesn't matter. You can always send me. Right. So next week I'm going to do numbers. Numbers means, as I told you, I'm going to talk about the arithmetic progression, geometric progression, and trigonometry as a whole, and also logarithms. I didn't discuss logarithm last time. So logarithms, trigonometry, arithmetic progression, geometric progression. Those are my main focus lessons. Okay. So if you have any problems and if you feel, if other lessons in number lessons are fractions, ratios, proportions, like man-based questions, right? Number of men doing a work. So if you have any doubts with those questions, you can ask me, so I can put those kind of questions also into the paper. So always students, just don't lose the connection, right? So I am trying my best to give you something. Yeah, next session also on Monday. It's every Monday, 7 to 9. 7 to 9:30. So I try my best to give you something. So if you have a doubt, you can always send me. I have a doubt in this part. So when you're making the paper, can you add a question from this part? So I can try, right? If that part goes with the lesson that I'm going to do on that particular day, then definitely I'm going to ready. So the next week I will be doing the number lesson. So if you have any doubt in number lessons in particular parts, you can send it to me. I told you what are the lessons I'm going to put inside the paper. Other than that, if you have anything, you can always raise via WhatsApp, or you can just text me. Yeah, whatever the medium you choose. Okay. So students, I think it's 9:50. Let's stop for today, right? I think you learned you did learn a lot of things today, and I'm really happy for that. So good night, everyone, and have a nice week. Okay, goodbye.